Welcome to the distance learning program on cloud computing by Innobus. In this chapter, we'll be covering the virtualization. We'll be covering the topics under virtualization, which are basics of virtualization, objectives of virtualization, benefits of virtualization, and emulation, and the virtualization for enterprises. Let's check out the basics of virtualization. Virtualization is the emulation of a hardware within a software platform. And the virtualization has three concepts. It has got a host choice, it has got a guest choice, and it has got a hypervisor. And host choice provides the host to one or more virtual machines, and it also helps to share the physical resources to its virtual machines. And it is where the virtual machines or virtualization products are installed. And the guest choice. The guest choice are which installed on top of a virtual machine, and it's completely, or it could be completely different from the host choice. And another part is hypervisor. Let's see what is a hypervisor. A hypervisor, it's also known as a virtual machine manager. And hypervisor is a program that allows multiple operating systems to share the hardware resources, by which each operating system that are running on top of the virtual machines seems to be or considered to be having individual processor, memory, and other resources. And hypervisor handles the resource allocation and sharing to its virtual machine from the hardware part. And the hypervisors are mainly divided into two parts or two types. First one is native or bare metal, and another one is hosted. Let's take a look at what is a native mode. As the figure indicates, the native or bare metal type of hypervisors are example of VMware ESXi, Xen servers, and IBM System C hypervisors. And also the Microsoft Hyper-V is an example of native. That means, as the name indicates, it's being directly installed on top of the hardware. And the figure which we see here is the one which shows the hardware part, which includes the CPU, memory, the networking component, and the disk or the storage. And on top of the hardware, we can see the hypervisor. On top of the hypervisor, we can see the virtual machines that are running different applications. And the hypervisor is the one which enables these virtual machines to use these hardware resources. It allocates, it shares these hardware resources between these virtual machines. And another type of hypervisor is a hosted one. As the figure indicates, the hardware part includes CPU, memory, networking component, and storage. And on top of which the host operating system is being running. On top of the host operating system, we can see the hypervisor. That means the hypervisors are being installed on top of the host operating system, which then shares the resource between the virtual machines. And it's usually used between the efficient side of virtualization, such as virtual PC or VMware workstation. All these are being examples, or all these are examples of hosted hypervisors. Now let's take a look at what are the objectives of virtualization. The first one objective of virtualization is it increased use of hardware resources. As we know, using the virtualization technique, the hardware resources are shared between different virtual machines, which results in increased use of these resources. The idle time of hardware resources will be lesser. And another objective is reduced management cost. The cost of running a web application in an individual server will be high when compared to running the same web application on a virtual environment, because using the virtualization technique we can share the hardware between one or more virtualized servers, which could be used for running one or more application, which in fact reduce the management cost of the hardware. Another part is improved flexibility. As we know, using the virtualization, we share the hardware using the hypervisor technique, and based on the requirement, this hardware can be shared or allocated between the virtual machines running on top of it, and this flexibility is being high on a virtualized environment, which could be much lesser on any other environment. And it also results in improved security and reduced downtime. As we know, the migration from one virtual machine to another is pretty much less than migrating it from one hardware server to another hardware server. As we know, even on hardware failure, these web services running on top of virtualized server can be easily migrated to another one, and it won't take much time, and which results in reduced downtime. And it gives maximum utilization of available resources. As we know, the idle time of resources are pretty much lesser in the virtualized environment, as by which we can get the maximum utilization of all the hardware resources. And now let's take a look at what are the benefits of virtualization. First one is easy to administrate. Why it is easy to administrate? As we know, using one hardware and the virtualization technique, we can run more than one web or any application, service application on top of it, by which we can have the administration pretty simple. The moving or the migration or the portability of these services are pretty much easy in virtualized environment. And let's see what's another benefits, which is elimination of compatibility issues. As we know, the virtualized environment or virtualization techniques that are available in the market supports all compatible architectures. It could be x86, x86-64, or ARM based processors. All these architectures are being supported by major virtualization techniques, and the compatibilities are very much eliminated in case of virtualization, and it results in increased security, and it gives efficient resource management. As you know, we share the resources between one or more virtual servers using the virtualization technique, and since by which the idle time of our hardware are pretty much lesser, which are being utilized to the maximum, and which results in efficient resource management. And portability. Imagine we have a web server which is running on a virtual machine. In case of any hardware failure, these web services can be moved from one virtual server to another virtual server pretty easily. Since there is no compatibility issues, the migration or the portability can be pretty much easier. Using the images, we can move one service from another web server, and which is the portability part, and it's a less time taking one as well. And the rapid deployment. The deployment of a web application onto the virtualized servers are rapid, since the resources are being shared based on the requirement of CPU or the memory. The deployment could be performed in a lesser time, and it results in improved uptime another one, it gives the problem-free testing environment. For testing our web application in a virtualized server is an easy task, and since there is no compatibility issues and the resources are being shared, and the testing can be a hassle-free task, which gives the problem-free testing in the virtualization environment. And also it is less expensive, since we are sharing the resources or our hardware between or more than one web application. That means using one resource for running two applications. Instead of buying two hardware for running two applications, we are sharing these resources. Obviously, it results in less expensive deployment manner. Now, let's take a look at what is emulation. Emulation, it is different from virtualization. And let's see how it is different. The virtualization is a part of running the web application using the hypervisor technique. And emulation, as we know, it is a second stage or second type of hypervisor. That means the hosted one. That is what is known as emulation. Here we go ahead and use the operating system are deployed to the host operating system, or the virtual machines are deployed on top of the host operating system. That's what is emulation, which is another mode of virtualization. And examples of virtualization or emulations are Microsoft Virtual PC or Oracle's VirtualBox, which the end user or the common man is using for creating a test environment or for running a normal web application into his or her machine. Now let's take a look at what are the virtualization techniques offered for the enterprise. We have VMware, we have Xen, and we have KVM. Now let's take a look at VMware. VMware is considered to be a world leader in providing virtualization products, and the product, which is ESXi, is an ultimate product in the virtualized environment, which is a global leader in the virtualization products. And the different products and solutions offered by VMware are divided into four major categories. They provide products and solutions for cloud and data centers. They provide products and solutions for small and medium business. The security products are there. At the same time, they do have desktop and end user computer products. Another virtualization product for enterprise is Xen, which is based on an open source technology, and it supports all major architectures like Intel x86, x86, 64, ARM based CPU architectures. All these are being supported by Xen. And AWS, Amazon Web Services, is an end user of Xen. The AWS virtual cloud is being created using the Xen hypervisor and Xen cloud platform. The products are offered by Xen are Xen hypervisor and Xen cloud platform. Xen hypervisor, it is an industry leader, and it is a thin layer which is inserted between the server's hardware and the operating system. As the name indicates, it's a hypervisor which comes in between the hardware and the software, and this allows to run more than one or more virtual servers effectively, decoupling the OS and its application from the underlying physical server. And another virtualization provider for the enterprises is KVM, which is known as kernel-based virtual machines. And virtualization solutions, it provides virtualization solution for Intel x86 based architectures, and it requires virtualization supported architecture. The hardware should be enabled or available with the feature of virtualization. For example, Intel's VT or AMD's AMD V should be enabled in the architecture for running the KVM. Thank you.